The CNF Testbed is an open source project that addresses the testing, deployment, and demonstration of cloud-native network functions submitted by the cloud-native community. One of the challenges that persists within the cloud-native movement is the elasticity of networking components. Provisioning the network capacity often still requires people to put in requests for hardware and configuration manually. The CNF Lab is a place where network provisioning, data plane configuration, network use case development and deployment, and testing methodology can be collected in one place. Provisioning is the act of setting up the hardware and preparing it for use. When provisioning hardware to be used for networking, we use commodity hardware and network cards, but minimize networking hardware with ASICs such as hardware routers and switches. This gives an opportunity for more elasticity when provisioning. When provisioning, we also need to take into account network-specific options for network cards and CPU usage when setting up the operating system. This includes setting BIOS options such as SRIOV and IOMMU. DPDK, when installed, makes use of these and other hardware functionalities if they are made available. For the management of hardware and operating systems, Terraform is used to set up the hardware and operating system, and Ansible is used to configure the BIOS and host network. A software network data plane processes packets for the network. Data planes use technologies such as the spanning tree protocol in order to solve network problems that involve all nodes in the network topology. The data plane is part of a solution for handling specialized network workloads and packet processing from layer 2, such as processing Ethernet frames, to layer 4, such as TCP/IP packets. VPP and OVS are examples of software network data plane projects. The data center and telecom industry are the target audience for the use cases that are examined in the test lab. Cloud-native network functions are the way these use cases are implemented. Some potential use cases are IP4 routing, segment routing involving IP4 and IP6, and layer 2 and 3 VPNs involving MPLS. To deploy the cloud-native network functions, we use Helm charts. We also use Helm to configure the container, networking, and data plane options. When testing, we deploy into multiple environments such as CSIT and Packet.net in order to independently verify the outcomes. We use NFV bench to handle the high output of the packets. The physical host and physical network cards use the provider's underlay Ethernet network for all outbound and internode connectivity. Within the test lab, the packets originate from a packet generator, but in a real setting, the packets will come from the internet or outside network, which attaches and configures two interfaces with two layer 2 VPNs to the host. When a packet comes into the host, it gets managed by the host's virtual switch, which uses a VPP data plane. The host switch sends the packet to the first container. The container has two virtual network interfaces and a VPP data plane. The first virtual interface receives the packet, and then it gets processed by the data plane. The packet then goes out through the second interface, back to the host's virtual switch, and into the second container. The second container has two virtual interfaces and a data plane as well. This packet comes in through the first virtual interface, gets processed by the data plane, and then back out through the second interface. The packet then goes back to the host vSwitch, and then, in the actual use case, back out to the internet or network through the host's NIC. In the testing scenario, NFV bench captures metrics for the packet at each stage in the test.